All rights reserved. No part of this document. Smart river purification scheme. Sewage treatment, power generation, smart conceptual sewage system for Varanasi, gravity flow and smart wetland treatment of sewage. Copyright will be reproduced, stored, printed, copied in any retrieval system, translated, transcribed or transmitted in any form or by any means, without the express written permission and laws of copyright, of Major Navin Chandra, retired, and Mapsets Engineering Services, henceforth mentioned Mapsets in the following simulation. This copyrighted concept will be customized as per the topography of all other cities.
Mapsets brings a permanently sustainable solution to treat municipal, industrial and storm-water sewage using an engineered tunnel to transport the sewage outside the municipal city, and treatment using wetlands for cities and towns on the banks of River Ganga without using any power, chemicals or skilled manpower needed. Operational for 24/7 and 365 days. Mapsets' basic philosophy is to collect all types of wastewater, including storm water, into underground tunnel reservoir. This underground tunnel will connect the existing sewage network and enable least amount of sewage blocking, which will drastically reduce sewer maintenance and at the same time eradicate surface water logging. With no water logging, the other infrastructure like road and other utilities do not get annual seasonal damages. The underground engineered tunnel reservoir will use no power to transport all the surface water sewage outside the city. This will gather huge carbon credits. At present, 80% of the water supplied in households and industries is drained into the sewage network system, which connects to a trunk sewer having underground screening chambers to filter the solid waste. This is transported using gravity or pumping to a sewage treatment plant. The pipe network gets choked during rainy seasons due to sludge and solid waste and design flaws. When the trunk sewer overflows, the untreated sewage empties itself in the lowest height of the River Ganga. Mapsets has proposed using the tunnel boring machines. This tunnel reservoir will be designed as per the projected MLD of 100 years. If the topography permits, the tunnel can be constructed below the River Ganga to service the city on the opposite bank. There will be no disturbance on the surface during construction and can be carried out during rainy seasons also. The tunnel will be a precast section by section 3-layered tunnel casing. The innermost lining will be of HDPE non-corrosive material and optical fiber to monitor the flow and maintenance cycles. The diameter of the tunnel will vary from 4 to 6 meters depending on the discharged MLD, the topography and the pressure needed at the starting of the wetlands. Average cost of construction of the tunnel will be Rs 50 crores per kilometer, and it will be tunneling approximately 30 meters per day. There will be vertical shafts to maintain and clean this single structure. There will be additional bypass structures planned which will have easy accessibility from the top. The design will be such that most sludge will collect only in these sections of the tunnel. Mapsets reviewed the Ganga Basin and undertook a pre-feasibility study of the city of Varanasi. In our report, we begin by identifying the land for constructing wetlands and a dry patch of riverbed marked in a red rectangle at 68 meters above mean sea level with over 340 acres of land patch available. In our smart sewer system we have proposed 100% collection with a life of 100 years. We have indicated two alignments, one in white color which is a straight alignment, the other is a curved alignment in yellow color covering a larger part of the city. The city information was collected by referring to the city development plan, and the existing sewage network was studied. A study of the Interministerial Group report of March 2013, according to which Varanasi has a total area of 10,058 hectares, the unsewered area is 8,432 hectares. There are 23 drains emptying raw sewage into the Ganga River. 84% of the municipal area is without any sewage network. The latest figures indicate a discharge of approximately 300 mLD in 2017. There are a total of 20 square kilometers of wastelands in the district. The ancient city of Varanasi is very densely inhabited. The proposed engineered reservoir needs no gradient and has the other opening on the north of the Gumti riverbed. There are two areas identified of 7 acres and 8.5 acres each. In case these lands are unavailable, the tunnel can be taken further to a place where land categorized as wastelands as per the Wasteland Atlas can be allocated to make the wetlands. The following simulation is for schematic representation only and the IPRs are owned by their respective owners. The tunnel and the wetland are uniquely designed for each city. The discharge and pressure for a wetland are maintained inside the smart tunnel reservoir. A revenue generation model of a break-even of 12-15 years through production of particle boards etc. is inbuilt, which will reduce tree cutting at the least, apart from providing a huge employment opportunity. Constructed wetlands are a viable treatment alternative for municipal wastewater and numerous studies on their performance have been conducted. A good design constructed wetland should be able to maintain the wetland hydraulics, namely the hydraulic loading rates and the hydraulic retention time, as it affects the treatment performance of the wetland. We propose to use wetland process where the sewer flows through a process of surface settlement tanks and then moves into the wetland cells. These cells are constructed to undertake a horizontal subsurface flow of sewer through grit and TFA vegetated tanks. A filtered system has 3 stages or zones. There is an inlet area where water flows through crushed bricks and stones. Then, water enters a treatment zone in which the same media are used, but in which the different plants are located. The water then enters the outlet zone. Once treated, the effluent can be used for irrigation and fisheries, or just draining it into the Ganga to maintain the environmental flow. Prototypes of wetlands made on a smaller scale yet cleaning approximately 1 mLD sewer in approximately 2 acres have resulted in just 1% energy requirement, 0 chemical application, 0 sludge generation, 50 to 65% reduced treatment cost, no skilled manpower requirement, harvested biomass is transformed to particle boards, and waste to power generation. Has a life of 100 years. They bring down the bad to less than 10. TSS 99% removed, pathogens 99% removed, fecal coliform 99% removed, iron 99% removed, chromium 99% removed, lead 99% removed. The most important aspect in comparison to the power and technology hungry STP is that these wetlands bring in huge carbon credits to India.